Okay, we're gonna work a problem, and it's a similar problem to what we did in class. It's a straight line, uniformly charged, and here we're gonna draw the line, and we're assuming it's positively charged. It's just a common assumption we'll do. We'll put an axis on here. We'll put a y-axis. Here's our y-axis, and an x-axis along the horizontal. Now what we're going to do differently, there's our x and y, is we're going to pick a different observation point. We're going to pick a point that is not a high symmetry point, just some arbitrary point, xy, right there. We've labeled it. And we're going to try and do this problem, calculate the electric field at that point. We're going to do it by using the full vector definition and then filling in all the pieces because we know how to do that. So we'll start with writing our little bit of charge. That little gray area is our little charge there. And we're going to draw an R vector. The R vector extends from the bit of charge to the observation point. That's going to be our R vector. And we'll label it R vector. And now we're going to go try and write out dE vector. And we know how to do this. We have dE is a vector, dq, there's the vector symbol, dq over 4 pi epsilon naught r squared r hat. That's the full vector form. So we have to fill in all the pieces. We can write dq, that's our little gray bit of charge, as lambda dx prime. And let's label the position of that charge as x prime 0. So we called the horizontal x prime to make sure we don't confuse it with the observation point. So we can write r is endpoint minus starting point, x minus x prime in the I direction, and y minus 0 in the j direction. So it's endpoint minus starting point. R magnitude is just the square root of the sum of the squares, x minus x prime squared plus y minus 0 squared. And then r hat, the unit vector, is r vector over r magnitude. And we've written those. So it's x minus x prime I plus y j over that square root, that big square root function, x minus x prime squared plus y squared square root. So look, I have everything now to set up the problem, to do all the physics. Let's kind of highlight what we have. So we've got dq, lambda dx prime, r vector, r magnitude, r hat, everything we need for that dE vector. So now we're going to substitute it in. We're going to fill it all in. So let's write it. dE vector equals, well, the dq is lambda dx prime. Yep. And then the denominator is 4 pi epsilon naught r squared. We'll fill in the r squared. The r squared is going to be that square root term squared, so that's why the square root goes away. And now it's going to be times r hat, so we'll just write r hat in the next line, times x minus x prime I plus y j over that square root term, the magnitude term. There we go. Now, it's going to be convenient, after we have this written out, to break it apart into x and y components. So let's write just the dEx, which is the I component. We're going to kind of gather all the terms together. dEx is lambda, there we go, lambda, dx prime, times that component in the I direction, x minus x prime, over 4 pi epsilon naught. And then you'll notice we gathered together those denominator terms to make this x minus x prime squared plus y squared 3/2. And that 3/2 is going to be super common. We're going to see that a lot. We can do the same with the dEy. and that's going to be lambda dx prime, that's our dq, times y, that came from the j component, and then over 4 pi epsilon naught times x minus x prime, quantity squared, plus y squared. Again, to the 3/2, we gather everything together. And now we have a complete expression that we can integrate. And we'd have to integrate from the left side of the line to the right side of the line, whatever that is. Here it looks pretty symmetric, but it's whatever it is. And so here we have, let's highlight them, dx prime, dy prime, dex and dy. And we've highlighted them. And all that's left to do for this problem is integrate. And we'd use some tool for that. We wouldn't do that, wouldn't necessarily do that by hand. You have to integrate from the left to the right. Okay, that's a nice problem.